Oh, hey there. So, I have some extra time on my hands now. And you know, one thing I always wanted to do was go scuba diving, right? I don't actually know anything about scuba diving though. I don't own any equipment, and I don't really want to spend any money. So here's what I was thinking. I'm an anesthesiologist, right? We know breathing systems. I feel like I should be able to steal enough equipment from the hospital to make scuba gear, right? Like, hang on one second. By the way, as an aside, you'll notice in the coming clips there'll be a little capnography and SpO2 display. In the following experiments, I'm going to do them live for you now. I also did them when attached to an anesthesia machine with a pulse ox on me to give you a live feed on what my pulse ox and my FiO2 would be, for example. So now, let's start out with this thing. This looks like pretty good scuba equipment, right? I feel like I can breathe through this thing. We got some open ends there. Well, if you talk to your friendly respiratory therapist, they'll give you one of these. There we go. All set. We have this solid corrugated circuit with a little filter on it, and I have the two ends tied together. There are little filters here. That's all it is. What do you think is going to happen if I try and take a breath? Let me try. That did not work at all. I cannot suck in at like a little bit, but then I feel like I'm producing negative pressure pulmonary edema. Why can't I take a breath? Well, think of this like a straw, right? It's like a giant straw, and it's not going to anywhere. So it's like a straw with my hand on the end. Can you take a breath through a giant straw? What if I just made the straw longer? Like if I extended this, would that make me be able to take a breath? No. What do I need to do so I can actually breathe in this thing? Well, what's the fancy word for the thing that we're talking about? Compliance. There's no compliance in the circuit right now. Effectively, there's a little bit of compliance because this is crappy plastic. But if this was hard plastic, there's absolutely no compliance in the system. So if I take a breath, I need to be able to move volume in and out. What can I add to the system to add compliance? What do we have on our system that adds compliance to the system? What about the bag? Hang on. These things come with bags. There we go. Okay, I gotta talk to the respiratory therapist for one more second. All right, so got myself a T-piece. So we hook that in there, There. Now, I got this, and then I got a bag just teed in there. That's it. Now what's gonna happen if I take a breath here? I can breathe. Think this is gonna work? Can I go scuba diving this? Want to give it a shot? Let's go. That was terrible. I really felt like the whole time I just couldn't breathe. Like I was breathing, I was moving air, but I just kept feeling like I had to breathe deeper and faster and faster. But I didn't desat, right? My CO2 was building up a little bit, but that CO2 just made me really air hungry, just really want to breathe. I didn't last very long. So what can we do to that's not gonna work. What can we do to make that better? All right. What do we do in our machines? How do we get rid of the CO2? Now, some people say flows. I don't want any flows. I just want in this circuit. How can I get rid of CO2 in this circuit? Well, we have the CO2 adsorbent, right? So now one question I have for you is that circuit did not have any sort of CO2 scrubber, anything on it, right? When I'm breathing in and out, if you looked at the capnogram's going up and down, right? When I breathe in and out, why is it going up and down if my CO2 is just collecting? It shouldn't, like, I breathe out, 35 centimeters of water, CO2. Shouldn't that be what I breathe in? Why is it going up and then I breathe in something lower than what I just breathed out? Where is that CO2 going? It's not getting absorbed anywhere. It's a sealed system. It's not going anywhere else. So think about this. Think about the amount of CO2 that I'm breathing out. I'm breathing out 35 centimeters of water of a tidal volume of gas, right? And I'm breathing that out into a circuit that's filled with however much other volume. So that much CO2 is going into a circuit that presumably has 0 CO2 in it. I'm blowing it into there. It's getting diffused around. And then what I'm breathing back is fundamentally less concentrated than what I'm breathing out, right? You'll notice this when you change the CO2 adsorber on your machine. Even when you remove it, you'll still get a capnogram that goes up and down, which you might be, why is it going up and down? It's going up and down because even without scrubbing, you're still going to lose things through diffusion into the circuit. It'll build up eventually, though. So first thing I have to do is I have to make this into a real circuit, right? This isn't doing anything for me. When I breathe, which one of these limbs am I breathing up? Well, both of them at the moment, right? There aren't any valves inside this thing. There aren't any valves inside this thing. I need to get some valves. Helpful respiratory therapist. Little one-way valves. So let's add those in. I'll put little one-way valves in. These are the same principle as what we have in our machines. They're little discs. The disc flaps up. When you blow, it flaps down and prevents you from sucking. Goes that direction there. And then let's put another one. Go in that direction. So now, flow can only go that direction. It can only go that direction. So now when I breathe, you can see the valve. All right. So now I have a one-way system. I know that I'm pushing air in one direction through my circle circuit, right? Now I need some adsorbent. That is going to require a slightly higher level of thievery. I'll be right back. All right. I grabbed an extension and I filled it up with CO2 adsorbent. It's the best I could do in these circumstances. All right. So now let me add that into our circuit. So now we have one-way valve. We have our bag, that's our compliance. We have our CO2 adsorbent that I'm going to obligate myself to breathe through. My other one-way valve. This going to work? Can I go scuba diving through this? Want to try it out? Let's go. So, not as terrible as the first time. Actually, not that bad at all. Really didn't feel that air hunger at all. The CO2 was really getting scrubbed. It's kind of hard to see on the capnography because I'm not really getting nice clean breaths out. But I really did not feel the struggling for breath. I was definitely getting hypoxic by the end, though, which is interesting because you really don't feel it. You just kind of start getting fuzzy. I really didn't even actually feel like I needed to breathe. I was just getting kind of lightheaded. So how can we fix that? I was down there a decent amount of time, but I'm still gonna run out of oxygen at some point. How long do I have before I run out of oxygen? How do I calculate how much oxygen I'm using and how much oxygen I have to work with? Let's just ballpark. Let's ballpark that I'm using 250 cc's a minute or something. The actual oxygen consumption varies a lot based on what I'm doing under anesthesia, swimming, huge variances. How much oxygen is in this? In like cc's. So we can just say it's basically room air, right? So it's 21% oxygen. 21% of what? Well, you have to look at the volume of this, right? So what's the volume of this? I don't know, but it doesn't look like much, right? I'm going to say half a liter or something. I don't know. So 21% times whatever this volume is, and then I'm using 250 cc's a minute, I'm going to burn through this pretty fast. How can I get more oxygen? So there's the easy way and the hard way. What is the easy way to get more oxygen out of this that I can do right now without adding anything else to it? You with me? You with me? Increase the volume, right? It's just 21% oxygen I'm adding. But I mean, this extends for a while. I can at least double, maybe triple this. I bet that's going to extend my time. I say we should try it out. All right. I wasn't counting time, but that looked pretty good. That was like 3 minutes or something. I thought that was good. I'm pretty happy with that. I feel like I felt comfortable. I could get some good scubaing in. Definitely still got hypoxic at the end. There's only so much O2 I think I can get out of that thing. I mean, I could add more like bags on and stuff like that. I feel like that's gonna be hard to keep underwater at some point. So what else could I do? How could I get more oxygen? I could add an O2 tank, right? Unfortunately, I don't have an O2 tank. I feel like they would notice if I took one of those from the hospital. But let me just kind of simulate what that would be like. Like, if I hooked up an O2 tank and I turned it to 10 liters a minute, right? It might look something like this. If I add volume to the system, I need a way of taking it away, right? So I could definitely add fresh gas. I could add a fresh gas input with some oxygen. I could even hook it up, have it flow through the vaporizers, so I could start adding anesthetic gases into here if I wanted to anesthetize myself while I'm scuba diving. But if I'm putting gas into the system, I need to take it out, right? So what do we do in our systems? How do we not have the system explode when we turn on the fresh gas? There's a pressure limiting device, and like an automatic pressure limiting device, or a valve, an APL valve, right? The APL valve that you turn, that sets the limit on the pressure in the circuit. If the pressure in the circuit gets above whatever you set, either nothing or any sort of pressure that it allows on the system, it pops off into, what does it pop off into? You follow the hose, goes from the APL valve into the scavenger. The scavenger is a system that balances where it's going to the circuit. Where it's going is the suction. You don't want to put suction straight to the circuit. That doesn't sound like it would work out very well. So you have this scavenger that balances the suction on the circuit, and then it just goes into the suction. It literally goes into the suction, and then I think it's shot out the roof of the building or something, which is where the whole argument about greenhouse gas effects and those sorts of things are. We're literally just shooting it into the air. So, something to think about. So, the circuit we built here, starting with obviously the part that goes to the patient. One-way valve, some sort of either the bag or the bellows is really what it goes here, going through a CO2 adsorbent. It's the same circuit as the low pressure circuit in the machine. If you look at your machine, depending on what machine you're looking at, like if you have an Apollo, the standard machine that we use in our operating rooms, you can literally follow with your finger. You can see all the pieces, you can pull out the machine, see the different parts. That's basically all there is to it. Add the fresh gas flow and then the scavenger, and there you go. The high flow circuit's a whole nother part of the machine, something to be aware of, but that's basically the principles of getting a working circuit together, a circle circuit like we do. With these principles in mind, think through different scenarios of kind of why do we need fresh gas flow? How much fresh gas flow do we need? Why do we need the bag? Like, what would happen if you put someone on manual and took the bag off? Would they be able to take a breath or not? What happens if the bag's emptied out? Those sorts of things. Hope thinking through these things is helpful for you.